All right, so 2.1, we are going to learn about transformations of quadratic functions. Last chapter, we dealt with transformations. We had shifts, stretches, shrinks, reflections, all that fun stuff. But this chapter, this section, we're focusing on quadratic functions, which are the ones that look like this, and the ones that are x squared. So describing transformations of quadratic functions. A quadratic function can be written in the form f of x is equal to a times x minus h squared plus k, where a does not equal 0. The U-shaped graph of a quadratic function is called a parabola. So again, we're dealing with our U-shaped graph here, and we have our x squared function. The lowest point on a parabola that opens up, or the highest point on a parabola that opens down, is the vertex. The vertex form of a quadratic equation is this. So we call this vertex form. And the reason why it's called vertex form is because our vertex is h comma k. So we can clearly see what our vertex is going to be here. We have h comma k as our vertex. And on our graph, our vertex is just our lowest point here if our graph opens up. If it opens down, our vertex is the highest point here. And our vertex is h comma k. So again, we learned in the last chapter that a number multiplied out front indicates a reflection and or a vertical stretch or shrink. So this A shows us if it's a reflection or vertical stretch and shrink. Reflection in the x-axis means that we multiply the outside by a negative. So if that A were negative, it would be a reflection in the x-axis. A vertical stretch is when A is greater than 0, and a vertical shrink is when A is greater than 1, and then a vertical shrink is when A is in between 0 and 1. So just remember, if it's a fraction, we shrink it. If A is a number greater than 1, it's a stretch. The H inside our parentheses is a horizontal translation, but remember this minus sign tells us that it's the opposite of what we think. So if we have a minus H, just the H would be our vertex. And then lastly, adding or subtracting outside is a vertical translation, so this would be up or down. So nothing new here really. We went over all of this in chapter 1. So here we have horizontal translations. So these are shifts left or right. When H is less than 0, it shifts left. When H is greater than 0, it shifts right. And don't forget, we have that minus H in here. So it's always going to be the opposite of what you think. So horizontal translations happen inside the parentheses. Vertical translations happen outside the parentheses. So that would just be when we're adding it to the end. So it shifts down when k is less than 0, and up when k is greater than 0. Okay, example 1. Describe the transformation of f of x is equal to x squared represented by g of x is equal to x plus 4 squared minus 1, then graph each function. So again, we've seen this function before. We know that adding 4 on the inside shifts our graph in which direction?
Left.
Left. So we go to the left, 4. What about...
I couldn't unmute.
No problem. What about subtracting 1 on the outside?
Down 1.
Down 1. Awesome. So our transformation that's happening here is we shift it left 4. And down 1 unit. And then we have to graph each function. So first let's graph our f of x. So our f of x function is just the x squared, so we're going to draw our parabola through the center there. And then our g of x, we take this same parabola, just shift it to the left 4, and down 1. So our new vertex is going to be there, and then we just draw our u through that point. So this is g of x. All right, let's look at number 3. What shifts are happening here? What transformations are happening here?
To the left 5 and up 1.
Perfect.
To the left 5 and up 1.
Awesome. Left 5 and up 1. So we shift left 5 and up 1. So our parent just goes through the origin there. That's our f of x graph. And then our g of x, we shift it to the left 5 and then move it up 1. So our new vertex is going to be right there. And then we just draw our parabola through that. This is our g of x. Okay, any questions from these 3 here? Now we're going to move on to reflections. Reflections and stretches and shrinks. So first, we're going to look at reflections. A reflection in the x-axis is when we multiply the outside by a negative. So remember, you just keep your x's on the outside. And it flips over the x-axis, so instead of opening up, it would open down. A reflection in the y-axis, we multiply the inside by a negative, but a negative number squared is going to be the same thing as that number squared. So remember, negative times a negative is a positive. So even if we had the positive of that. So that's why when we reflect it on the y-axis, it doesn't change. So reflections on the y-axis happen inside, but when it's just an x on the inside, our graph doesn't change. Next, we're going to look at horizontal stretches and shrinks. So horizontal happens on the inside. A horizontal stretch is when we have a fraction, so some number being multiplied to our x that's in between 0 and 1. So this is a stretch when we have a fraction. And then when we have a number that's greater than 1, we have a shrink. So just think, horizontally stretching, you're stretching it out horizontally. Horizontal shrink is when you shrink it in horizontally. And the next we have a vertical stretch or shrink. So this is when the outside of x is being multiplied by a number. When that number is greater than 1, we have a vertical stretch. And when that number is a fraction, we have a vertical shrink. So vertical stretch is when you stretch it vertically up and down, so the graph is getting skinnier. A vertical shrink is when you shrink it up and down, so your graph is getting wider. Okay, we have 2 more examples here. Actually, I think we have 3 after this, so 5 more examples. Describe the transformation f of x is equal to x squared represented by g, then graph each function. So we're doing the same thing here. What does this negative here tell us? Negative on the outside. What happens to our graph when we multiply the outside by a negative?
Reflection.
A reflection on what axis?
The x.
Perfect, a reflection on the x-axis. And then what about this 1/2?
Wait, why would it be on the x-axis if it's like there's no parentheses?
If there's no parentheses, then it's on the outside. Because if we just had, let's say we had a negative x squared. If we were plugging a number in here, let's say we plugged in 2, this would be a negative 2 squared. The squared is only happening to that 2, and that negative just gets tacked on at the end. So that negative is on the outside. We're not squaring the negative. So when there's no parentheses, it's on the outside. What does the 1/2 do? Is the 1/2 on the outside or inside?
Not on the outside.
It's on the outside.
No, the 2. Like, what would happen?
What was your question?
You were saying something about, like, the 2 being outside, or, like, in the parentheses. Like, what were you saying?
Here?
Mm-hmm.
So if we plugged in a number for x, we would just plug it. So if we had a negative x squared, and we were plugging in a number for x, let's say we plugged in 2, we would have a negative 2 squared. The 2 squared would be 4, but we still have to keep that negative on the outside because we're not squaring that negative. But if we had parentheses, this would be different because then we're squaring that negative, and a negative 2 squared would be a positive 4. So these are 2 different things.
Okay. Thank you.
You're welcome. All right, going back to our example here, what does the 1/2 tell us?
Vertical shrink.
Vertical shrink, awesome. So going to our graph, we start with our graph of our parent function. A reflection on the x-axis means that we flip it upside down. So it's going to look like that. And then we have to apply this vertical shrink. So if we're shrinking it vertically, we're making it wider. So our graph would be wider than the start, so it would look like that. So those vertical shrinks makes our graph wider. So just think we're shrinking it vertically, so we're compressing it down, we're making it wider. Let's look at B. What does this 2 on the inside tell us?
It's a horizontal stretch.
Awesome. horizontal. If it's a 2 on the inside, then it would be a horizontal shrink. Because remember, when it's inside, it's the opposite of what you would think. So you would think that the 2 would make it stretch, but since it's inside our parentheses, it's actually a shrink. So we have a horizontal shrink, and then what does this +1 tell us?
Up 1.
It's shifting, yeah.
Up 1. Awesome. So now we just need to graph it. We start with our f of x graph, and then graphing our g of x. We have a horizontal shrink, so we are shrinking it horizontally, so we're squeezing it in, so it's going to make it narrower, and then we shift it up 1, so it's going to start right there, up 1, and then it's just going to be more narrow. So the horizontal shrink makes it more narrow. Okay, any questions here? All right, next page, we have 3 more examples, then we're done for today. So what does this 1/3 inside our parentheses tell us?
It's a horizontal shrink.
It's a horizontal stretch, because remember, it's the opposite of what we think when it's horizontal, so a horizontal stretch. And then that's the only transformation happening, so we can go and graph our f of x. Will look like this. And then a horizontal stretch means that we're stretching it out horizontally, so we're making it wider. So our graph will look like this. Any questions on that one? All right, let's look at 5. What does this 3 on the outside tell us?
Vertical stretch.
Perfect, vertical stretch. So if we're stretching something vertically, we're pulling it up and down. Is it going to get wider or narrower?
Narrower.
Perfect. So this is going to get more narrow. And then what about this -1 on the inside?
Right 1.
Perfect. Right 1. So let's graph it. We'll graph our f of x here. And then our g of x, we're making it more narrow and we're moving it to the right one. Any questions on this one? Okay, last one. Here we have 3 transformations that are happening. What does this minus outside tell us? This negative
Reflection on the x.
Perfect, reflection on the x. What about this +3 on the inside?
Left
To
3.
the left.
Awesome. And then this +2 on the outside?
Up 2.
Awesome. Up 2. So now we graph it. We have our f of x there. We have a reflection, which means we're going to flip it upside down. Then we move it to the left 3 and up 2. So our new vertex is going to be right there, and then we just flip it upside down. So this is our g of x. Okay, and this is where we're going to end today. You do not have to turn in your notes today. And we're going to do the last 2 examples tomorrow. Any questions from today?